Hi everyone. Imagine you are a tourist who only speaks English in Seoul. It's 30 degrees C, and you ask your AI agent, how can I get there? Your AI agent might say, it's a 30-minute walk. The answer is correct, but it isn't enough. This should also account for the fact that you've already walked for 10 kilometers today and may be thirsty. So our research question really is, how can we evaluate whether travel agents account for critical human factors without running a user study? The original motivation comes from SeoulWalk, which is an app I developed with my teammates in the Human AI Interactions course taught by Professor Taehyun Kim. However, to expand the research for this project, I introduced a new dataset as well as a new evaluation metrics. Here is the research pipeline. I first generated the dataset of 20 samples, which I call SeoulWalk-Bench, and then I set up 3 different prompt configurations to experiment with. I ran inference on our vessel cluster and then used an external model to be the LLM judge. And finally, I analyzed results. The benchmark spans across 5 different task types, as well as 8 different tourist situations. However, the data set had to be reduced because there was not enough time to make all 50 samples. So first, I will demo the dataset creation tool. So here is an example. You can drag and drop images through this tab. And here is the query that will be the user's question to the LLM, to the travel agent. Here, you can actually go to Google Maps and choose any location. For example, if I wanted to add this location, maybe this location to dataset, I can copy the Google Maps Plus code, and paste it here, and then it will convert it to the latitude and longitude, and I can apply to the sample. There are also each data sample contains the user query and context, but there's 2 types of context: conditional context and context that is always attached. And so we can also modify that. Now I introduced the 3 different types of prompt conditions. The vanilla VLM is very simple. It just takes the question image and a prompt. All context prompts include all the context, including the conditional context I mentioned earlier. And in the case of SeoulWalk, not all context is included. SeoulWalk itself has a classifier that determines and conditionally accepts contexts, depending on what it thinks is relevant. So here was the CHF reward metric. CHF reward, which is one of our core contributions, is a linear combination of the scale factor, and each of these 4 different types of categories. These 3 add to the reward, and the overclaim penalty penalizes the reward. Here are the results. The judge model I used is Sonnet 4.6, and I tested on 2 answers models, both based on the Q4 quantization of Gemma 4 model. And in general, the reward is highest for SeoulBench. But I believe the reason for that is because the prompt explicitly tells SeoulWalk to use critical human factors in the response, while the other 2 do not prompt them to do so. Another thing I noticed is that the overclaim score is higher, but the overclaim penalty is higher on SeoulWalk, which means there might be competing goals when you're trying to maximize human comfort, but also provide grounded answers. The limitations of this project are that the benchmark is small with only 20 samples, and the LLM can be noisy because we only tested it with 1 specific prompt set, and maybe small changes in the wording can affect the results. The models we used are all based on the Gemma 4 family, so maybe with different models, performance can vary. And also, it's not a user study, and there's no guarantee that higher scores lead to safer travel assistance. And also, the inputs are often screenshots of Google Maps images, and sometimes they were also generated by AI, so the test distribution do not represent real-world distributions. Thank you for listening to the presentation.